Good morning, students. My voice is audible. Can you see my screen?
Yes, sir.
Okay, thank you. You're fine, students. Mm. In today's class, let us begin with Java. So, these many days, we have seen C++. From today's class onwards, we are going to study about Java. Okay. See, Java is a very good programming language. Very good. Java is a very good programming language. Okay. So why I say it's a very good programming language, because from Java only several programming languages has been evolved. For example, when you take C sharp, yeah, the C sharp has been evolved from Java, right? When you take Python, so Python also has been evolved from Java. Can you take any object oriented programming language? Any object-oriented programming language has been evolved from Java. So Java is the first object-oriented programming language. You may say, sir, C++ also is an object-oriented programming language. That's 100% correct. C++ also is an object-oriented programming language. That's true. But this Java is pure. It is pure object-oriented programming language. What do you mean by pure? Pure means anything. Anything can be represented in terms of object. Okay. In Java, anything can be represented in the terms of object. But C++ is not a pure object-oriented programming language. It's a just object-oriented programming language. But whereas Java is a pure object-oriented programming language. What you mean by pure object? For example, let us assume that, okay, int a equal to 10. Int a equal to 10. I have written. What is a? A is a variable. A is a variable. A is a variable. Okay. A is a variable. A is not an object. A is not an object. A is a variable, right? But in Java, we can represent uh, a variable of type int in terms of object. Okay. In Java, what we can do? In Java, we can represent a variable of type int into object. So that's why not, it can be anything. Anything can be represented in terms of object. So that's why we call Java as a pure object-oriented programming language. The word pure says that anything can be represented in terms of object. Okay. Now, James Gosling, okay, James, James Gosling. James Gosling, he is a person who has introduced Java in Sun Microsystems. Okay, James Gosling is a person who has introduced Java in Sun Microsystems. Okay, in Sun Microsystems. Okay, he's a person who has introduced Java. Okay, the name of the person is James Gosling. In other words, he has invented this Java programming language. Okay, anyhow, fine. Uh, these are some of the things which I would like to tell. But the most important thing is Java is a very good programming language. Okay. So if you know Java, I say you know C Sharp. If you know Java, I say you know Python. Why? Because the concept remains the same. Okay. The concepts remains the same. What changes? Only the syntax. Only the syntax changes. Okay. So syntax from Java varies from C++, and similarly it varies with respect to Python also. Okay. So if you're good at concepts of Java, easily can understand C Sharp and easily can understand Python. Okay, there's nothing tough. Only one thing is you need to make it out the concept. You need to make it out syntax. Okay. Okay, fine students. Let me clear my drawings. Let me clear my drawings. In today's class, let us begin let us begin with how to write a simple Java program. Okay, in today's class, let us begin with how to write a simple Java program. Okay, in other words, to how to write how to write a Java program. Okay? That's what you are going to see in today's class. How to write a Java program or how to write a Java code. Okay. Now, so initially, let me begin with writing a simple C++ program. Since these many days you have studied a C++, okay, let me write a simple C++ program. So let me write it. Main, void main, mhm. And inside this you write cout. Welcome, welcome, right, welcome. And above you're trying to include header file called hash include iostream iostream.h. Right. So these show you're going to write a simple C++ program in order to print a text called welcome. Right now, the same program. Let me try to convert into a Java program. Okay, the same program. Let me try to convert to a Java program. This is a C++ program, right? Now, with respect to Java, there is no concept of header files. Okay, with respect to Java, there is no concept of header files. So let us remove this header file. Okay, I repeat, with respect to Java, there is no concept of header files. Okay, so let us remove this. Now, so as we know that program execution always begin with main method. Okay, program execution always begin from main method. But in Java, in order to write a main method, okay, before void, we are going to prefix with public
Public
static
static void
void main.
void.
So these so we are going to write a Java. These so you are going to write a main method in Java program, right? And not only that, inside the main method, you are going to pass an argument. An argument is nothing but it's an array of string. Inside the main method, what we have to do, we'll be passing, we are going to pass an argument which is of type string. And the most important, it is an array of string. Okay, so that's why actually I put this square bracket. Okay, you see that I put the square bracket. The square bracket indicates that it is an array. ARG is an array. Okay, and the array is of type string. Okay, that's fine. So now in C++, in order to print, I'll be using this cout. But in Java, instead of using cout and followed by insertion operator, here I am using cout and followed by insertion operator. Now instead of doing like this, in Java, what we'll do, this statement will be replaced with system dot out dot println. System dot out dot println. Okay. So this is how you are going to print. So whenever you want to print anything on your monitor, we are going to use a statement called system.out.println. Okay. So inside this, whatever you want to print on your monitor or your console, the text you need to place inside your double quotes. Okay. Now, the most important thing in Java, any code which you write, okay, any function. See, what is a main? Main is a function, right? In C++, we are going to call main as a function, but with respect to Java, we are going to call functions as methods. Okay, the most important here I am going to call this as methods. What is methods? A method is nothing but it's equal to functions. Nothing but equal to functions. In Java, we call them as method, but in C++, we call them as functions. That's all. There's no difference. Okay. In Java, we are going to call functions as methods. Okay, but in C++, we're going to call as a function. Okay, that's one important difference. You need to make it out. And one more thing, in Java, any code which you write, it must be encapsulated inside a class. In other words, any code which you write, it must be placed inside a class. See that? Is this true? You see that this entire code I have placed inside the class. Okay. Any code which you write, it must be placed inside your class. So you see that this is the main code, it's the main program I've written. The main program I've written. This entire main program, what I've done, this entire program I've encapsulated inside a class. You see that I've encapsulated inside a class. You see that the entire program I've encapsulated inside a class. This is very, very important. You need to make it out. It's mandatory. Okay. So in Java, whatever you write, everything we write in terms of classes. Everything we write in terms of classes, right? In other words, we are going to encapsulate everything inside a class. Okay. Okay, fine. Let me clear it. Let me clear it. Now, let me write a comment. This is my first program written today. Written today. Sample program. Yeah. Okay, fine, students. Yeah. So here you can see that students here written how many statements? I've written 3 statements. 1, 2, 3. Right? In other words, 1, this is 2, and this is 3. These 3 statements I've written, but these 3 statements I have placed inside this. These 3 statements are placed inside this. We call this as multi-line comments. We call this as multi-line comments. We call this as multi-line comment. Hmm? What is multi-line comment? The multi-lines, what's the meaning of multi-line? The multi-line says that more than one line, right? Here, how many lines I'm having? You see that totally I'm having 3 lines. So that's what it is, multi-line. The name multi-line says that it is more than one line. So more than one line, if you want to comment, more than one line, if you want to comment. Sorry, students, 1 second. Yeah, I'm back. Yeah. More than one line, if you want to comment, okay? More than one line, if you want to comment, you should use this multi-line comment. So using this, that is backslash star. Inside this, we are going to write multiple lines. And then once you finish, we are going to put star and then backslash. So we call this. Here's I'm beginning with backslash star. I'm ending with star backslash. Okay. So we call this as multi-line comment. We call this as multi-line comment. Why multi-line? Because multiple lines. The multiple lines I'm trying to comment. So that's why we call this as multi-line comments. Okay. And next you see that students here I've written sample program. I've written sample program. And before that, as you see that what I've done, I put 2 forward slashes. I put 2 forward slashes, and we call this as single line comment. We call this as single. We call this as single line. We call this as single line comment. Single line comment. Okay. What it means? So if I want to comment a single line, if I want to comment a single line, I need to use 2 forward slashes. Okay. If I want to comment, a single line, I should use 2 forward slashes, and that's what I've done here. Okay. I want to comment sample program, so that's why I use 2 forward slashes. What is multi-line? if I want to comment multi lines, okay, if I want to comment multiple lines, what I should use? I should use this backslash star. It begins with backslash star and ends with star backslash, and that's what I've done here. Okay, this ending with star backslash, and it's beginning with slash star. Okay, so these are the two important types of comments in Java. Okay, in Java, whenever you want to write any comments, you can pick either multi-line comment or you can pick a single line comment. So when we should pick multi-line comments, so whenever you want to comment multiple lines, that's what I've shown here. Okay, in such a case, you should go for this multi-line comment. And whenever you want to comment a single line, then you should go for this single line comment. Okay. Now the big question comes in your mind. So why we should write these comments? Okay. See, the most important thing here, students, when you compile the program, as you know that once you write a program, this is my complete program. Okay. A program, we call this as a source code. Okay. We call this program is enter. I think you must know in this. Okay. We call this enter program as source code. Okay. So once you finish your source code, what you're going to do? You're going to compile the program. You're going to compile the program. Okay. When you compile the program, when you compile the program, this compiler, what it does, it ignores comments. It ignores comments. It ignores comments, and it considers only the Java statements. What are the Java statements? Class demo, opening floor brace, public static void main, system out dot println, and this opening floor brace, closing floor brace, and this. It ignores comments. Okay. If my compiler is ignoring comments, then why I should write comments? That may be question in your mind. See, writing comments is very, very good practice. Writing comments is very, very good practice. Is very, very good practice. Why we should write a comments? Because a comments describe what a program does. I repeat, a comment describe what a program does. Okay. See, today you have written the program. Today you have written the program. Probably after 1 month or 1 year, you left the company. Once you left the company, a new person has joined the company. When a new person has joined the company, what he has to do? He needs to go to the code. He needs to go to the code which someone else has written. Okay. Now, if you write comments something like this, a comments describe what a program does. In other words, a comment describes what a code does. Okay. So by reading these comments, you can easily understand actually what a particular method is going to do or what a particular statement is trying to do. Okay. So if you're not writing any comments in your program, so it makes very difficult for a person to understand. Not only for a new person, for you also you'll find difficult because you'll be writing some 1,000 lines of code, 1,000 lines of code or 10,000 lines of code. You'll be writing so many lines of code. Okay. So it's very difficult to make it out actually what you've written. So once you write the comments, by reading the comments, we can easily make it out what actually the code trying to say, right? So that's why writing comments is very, very important inside your program. That's all about comments. Yeah, fine. So I finished with comments. Anyhow, let me remove this comment so that I can focus more on the remaining part of the code. So writing comments is very, very important. Why it's very, very important? Because comment says what a program does. I repeat, a comment says what a program does or what a code does. Okay. Now, so how to write a Java program? Right? You see that it begins with class. It begins with class. Okay. Class is a keyword. Okay. In Java, class is a keyword. Okay. When I say keyword, it must be written as it is. Okay. The most important thing is in Java, all keywords must be written in lowercase. In Java, all keywords we should write in lowercase. It's very, very important. You need to keep in your mind. Okay. In Java, all keywords will write in lowercase. You need to remember. Why we should remember? Because Java is a case-sensitive programming language. Java is a case-sensitive. Java is a case-sensitive. Java is a case-sensitive programming language. Programming language. What is a case-sensitive programming language? What is a case-sensitive? It says that uh, I'm quite sensitive to the case. Okay, I'm quite sensitive to the case. What is sensitive? For example, I said we need to write class in lowercase because class is a keyword. Class is a keyword. Okay. Now, instead of writing like this, I can't write C in uppercase. I can't write C in uppercase. Why? Because Java is a case-sensitive programming language. Case is nothing but it is either uppercase or lowercase. Here I said that everything must be written in. I said everything must be written in lowercase. But what I've done, the first letter I've written in uppercase. I've written in uppercase. I've written in uppercase. In the remaining letters, that is A's, I've written in lowercase. That is wrong. That is wrong. You can't do like this. I can't do like this. Why? Because Java is a case-sensitive programming. It's quite sensitive to the case. That is, instead of writing lowercase, if I write in uppercase, it throws error. I'm quite sensitive. Okay. I'm quite sensitive to the case. If you say something should be written in lowercase, you must write in lowercase. You can't change the lowercase to uppercase, even though that is correct. Even though the class both are correct, but what you have done, instead of writing in lowercase, you have written in uppercase. It is quite sensitive. Since it is quite sensitive, it throws an error. So that's why I said that it's very, very important. In Java, all keywords must be written in lowercase. Instead of lowercase, if you try to write in uppercase, then this Java throws an error. Java throws an error. That's why it's very, very important. You should keep in your mind. Okay. So anything which is in lowercase must be written in lowercase. Anything must be written in uppercase. It must be written in uppercase. The most important thing you should keep in your mind with respect to Java, right? Yeah, fine. So let me clear my drawings. Okay. So after class, we have demo. After class, we have a demo. What is this demo? Demo is nothing but is a class name. Demo is a class name. It's a class name. The class name can be any name. It can be any name of your choice, but it should not be a keyword. Okay. So the name of a class, it can be any name, but it should not be a keyword. So right now, I pick the name of the class as demo. Once you pick the name of the class as demo, okay, the class begins. The class begins with this opening floor brace. My class begins. My class begins with this opening floor brace, and where it ends, my class ends with here. My class ends with closing floor brace. Here it is ending. It's very, very important. My class begins with opening floor brace and it ends with closing floor brace. Okay, fine. And let me clear my drawings. Yeah. The most important thing, students, here, with respect to C++, once you define a class, at the end of the class, you're going to put semicolon. Is it right? You're going to put semicolon in C++. But in Java, you should not put this semicolon. If you put semicolon, it throws an error. So when you're defining any class in Java, at the end of uh, closing floor brace, you should not put semicolon. Okay. So what I should do, you need to remove this. You should not put semicolon. Okay. But that is not case with respect to C++. With respect to C++, what we should do, once you define a class, at the end of class definition, you need to put semicolon. But that is not true in the case of Java. Is one of the important observations you should do. Since you're studying both C++ and Java, sometimes students may get confused. Students may get confused and they may put here semicolon. That's not correct. You should put semicolon only for C++. You should put semicolon only for C++ class. But when you're writing Java, with respect to Java, you should not put semicolon. You should not put semicolon. You right, students? Yeah. But that is one more important observation. You need to make it out. Okay, fine. Now, we are finished with this. Now, inside this, as you know that program execution begins from main method. Begins from main method. Now, here you see that, okay, I'm beginning with a keyword. It's not a keyword, it's a main. Okay, I'm beginning with main. And this main is having a return type of void. What is void indicates? Okay, what is main? Main is a method. Main is a method. Main is a method. Okay, as you know that a method can return a value. Okay, where my method is beginning, my method begins here. Okay, I open the flower base. My method begins here, and where my method ends, this is where the method ends. The method ends here. Okay, You see the students inside this. So inside this beginning flower base and closing flower base, I have not written any written statement. There's no written statement. Since the main method is not returning any value, the return type of this main is void. If main is returning any value, then we are going to change the return type. Since the main is not returning any value, the return type here is void. Okay, that's what your prefix with void. Okay. Now, now, um, let me next. Next, you see the students. I have written a keyword called static. I have written a keyword called static. In C++, we have studied about static. Is it right, students? In C++, we have studied about static. Why we'll make a function as a static in C++? In C++, when we make any function as a static, what's the advantage? We have studied, students, in C++. Anyone? In C++, we have studied. Okay, we have studied about static keyword. We have studied about static. We have studied about static keyword, right?
Sir, memory will be allocated explicitly, sir.
That is with respect to variable. Anyhow, your answer is good. That is with respect to variable. Static int a. That is with respect to variable, right? Static int a. I'm not talking variable. I'm talking with respect to function. Okay, fine, students. See, probably might have forgot. Okay. See, when we make anything as a static, anything which is static can be called with respect to class name. Okay. See, whenever you want to invoke a member of a class, what is main? Main is a member of a class called demo. Is it right, student? Main is a member of a class called demo. Why I'm telling main is a member of a class called demo? Because this main method has been defined inside the class. Since main method is defined inside the class, we call main as a member of a class called demo, right? Now, in order to invoke or in order to call this main method, what I should do? I need to create an object of a class called demo, and using this object, I need to call this main method. But here you see the students, I have made this main method as a static. Since I made this main method as a static, there is no need for me to create an object of a class called demo. So without creating an object of a class called demo, I can invoke this main method. How I can invoke this main method? Without creating an object of a class with respect to class name. Using class name, what I can do? Using class name, I can invoke this main method. Okay, so that's why we have made this main method as a static. I repeat, student, why we made this main method as a static? Because I'm going to invoke or I'm going to call this main method without creating an object of a class. In other words, directly with respect to class name, I'm going to call this main method. Here I'm telling I'm going to call this main method. I am means who is calling? It is JVM. Okay. It's not I, it is JVM. It is JVM. What is JVM? JVM stands for Java. JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. Is it right, students? This JVM stands for Java Virtual Machine. It is a JVM which is going to invoke your main method. Okay, I said I, it's not I, it's a JVM which is going to invoke this main method. How it's going to invoke this main method? It's going to invoke this main method with respect to class name. Okay, it is not going to create an object of a class called demo. Okay, how it's going to invoke? It's going to invoke this main method with respect to class name. So that's why. So in order to invoke this main method with respect to class name, I need to prefix with a keyword called static. Okay, if you remove the static keyword, then your program does not work. In other words, your JVM cannot able to invoke this main method. So mandatory, you need to write this you need to write this static keyword. I hope you understood what is the significance of this static keyword. Okay, because JVM is going to invoke your main method with respect to class name. So in order to achieve this, it is mandatory that you need to prefix with the keyword called static. Right? Yeah, fine. Yeah. So I'm done with static. And the most important thing is it is a JVM. JVM stands for Java Virtual Machine. But in short, all will call it as JVM. So you should know that when I say JVM, it's nothing but is Java Virtual Machine. Okay, it's a JVM which is going to invoke, or it's a JVM which is going to call your main method. Okay, how it's going to call with your main method? It's going to call with, it is going to call the main method with respect to class name. Okay, fine. Now you see the students, and next I have prefixed with the keyword called public. So what is the meaning of public? I think we have discussed this public keyword with respect to C++. What's the meaning of public? Anything which is public, anything which is public is visible throughout the program. Anything which is public, it is visible. Okay, and I say public, uh, public means it is visible. Private means, let us assume, and let me clear all my drawings. Now, let me try to illustrate this. Now let us assume instead of public, I made this private. This private. Let us assume I made this private. Private. And this is my code. This is my source code. This is my source code. Okay. Fine. Let me change the color. Yeah. Now you see the students. Now what I've done, I made this main method as private. So when I make this main method as private, means this main method is visible. This main method is visible within this opening floor brace and closing floor brace. Okay. When I make this main method as private, this main method is visible between this opening floor brace and closing floor brace. Outside of this closing floor brace, outside of this closing floor brace, this main method is not visible. Why it is not visible? Because you made it as private. Private means this main method belongs to a class called demo. That's all. It's a property of a class called demo. Since it is a property of a class called demo, this main method is not visible outside of the class called demo. That is outside. That is outside this closing brace. Outside this closing brace, you can't find this class called demo, right? Why I made it a private, right? See, I hope you understood. See, right, students? When anything which is private means, I have said this main is a private. When you say main is a private, then this main method belongs to class called demo only, right? Why it belongs to class called demo only? Because this main method I've defined inside the class called demo. Since I've defined the main method inside the class called demo, okay, this main method belongs to class called demo. And not only that, what I've done, I prefix with the keyword called private. When I prefix with the keyword called private, and this main method belongs to class called demo, right? Now, I don't want to make this as private. I don't want to make this as private. So what I'll be doing, I'll be prefixing with this. I'll be prefixing with public. Okay? I'm prefixing with this public. Okay? When I prefix this public, what's going to happen? You'll see that. 1 second. Now, when I prefix this as public, what is mean by public? I think public property and private property. Okay, now I made this main method as public property. Since it's a public property, this main method belongs to class called demo. And not only class called demo, okay, outside of this class called demo also, outside the class called demo also, this main method is visible. In other words, outside the class called demo also, I can call this main method. Not only outside of this class, outside of this program, outside of the program. That's very, very important. I would like to convey this. Outside of the program. When I say outside of the program, this is my source code. 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 Now, outside of the source code also, outside of the source code also, what I can do, I can call this main method. Why I can call this main method outside of the source code also? Because the main method is a public. Okay. Now the question comes, why I should make this main method as a public? Just now I said it is a JVM, is a Java Virtual Machine, which is going to invoke your main method. In other words, it is your JVM which is going to call your main method. And what is JVM? JVM is nothing but is a program. JVM is a program which is running outside of your source code. And this JVM needs to call this main method. So JVM, in order to call this main method, it is mandated that you need to make it as public. If you don't make this as public, and then this main method will be visible within the class called demo. Okay, so that's why you need to make this main method as public. So once you make this main method as public, then this JVM, which is running outside of your source code, can invoke this main method. I don't know, students, you got it? Understood? No? Oh, it's quite simple. This is my source code. This is my source code. This is my source code. Okay. JVM. JVM, this Java Virtual Machine. Java Virtual Machine, nothing but it's a program. This JVM needs to call your main method. JVM needs to call your main method. What is JVM? JVM is nothing but it's a program, or it's a code. It's a code which is running outside of your source code. Okay, this JVM, in order to call this main method, what you should do, you need to make this main method as public. Okay, public means this main method is visible. This main method is visible inside the program. Okay, inside this program, and not only inside the program, it is visible outside of the source code also. Visible outside of the source code. Outside of the source code. Outside of the source code also it is visible. Since it is visible outside of the source code, this JVM, what it can do, it can invoke this main method. Actually, you can think something like this, students. See, for example, this is a class. This is a class. Inside this class, there are some students are there. The students are there. Students are there. And there's one person standing outside. There's one person standing outside. Let us assume this person has JVM. JVM. Okay. Let us assume this person is nothing but it's a main. He's a main. Okay. This person name is main. Now JVM wants to call this main method. This JVM, what it has to do? It has to call this main method. Okay. Okay. It has to call this main method. Now, how this person can call, see, he is inside the classroom. He is inside the classroom. If he's inside the classroom, how I can call? I can't call him because he's inside the classroom, right? So in order to call, see, this person, in order to call this person, what this person has to do? This person has to come out of the classroom. This person has to come out of the classroom. Once this person comes out of the classroom, then only this person, that is JVM, can see this person. Once he sees a person, and then only he can call. Then only he can call him. If he is inside the classroom, how we can call? He can't call. Okay. Once he comes out of the classroom, then only this person can call him. Right. Here also, why I made this as public? When I make this as public, this main method will be visible outside of the source code. Once the main method is visible outside the source code, and then this JVM can call this. Then the JVM can call this main method. That's what actually it is all about. I don't know. You know, it's fine. Anyhow, understood, student? No? Yes or no? Understood? No? Understood this, student? Anyhow, once the session gets terminated, you can use the same link to rejoin again. Okay? I know why you're not understanding. I don't know. See, this is class called fourth K. You're a classroom. Inside the classroom, one person is sitting. One person is sitting. One person is standing outside. One person is standing outside. A person standing outside can call him. A person who is inside, he cannot call. He cannot call.